myself, Dr. Priti Jagwani from Department of Computer Science, Aryabat College, University of Delhi. So as you all are aware that presently we are learning artificial intelligence course, and in my first inception lecture of artificial intelligence we have looked into what actually the definition of AI is, and what is we also understood the difference between strong AI and weak AI, and we also looked into the 4 approaches of AI categorization, which is thinking rationally, thinking humanly, acting rationally and acting humanly. So in this lecture we are going to look into various interdisciplinary dimensions of AI, which we call as foundations of AI, and then further we will proceed with the agents and their environments in detail. So when we talk about foundations of AI, we looked into all those dimensions, all those faculties, all those interdisciplinary areas which are there to make AI in a complete sense. So AI also includes kind of some kind of philosophy, because we are going to deal into dualism versus materialism, which is a mind body problem, or we can kind of going to look into, can formal rules be used to draw valid conclusions. So that's a philosophical approach. Mathematics definitely involved in this, because we are going to look into so much of logic, then computations, probability obviously is involved, and all those algorithms, interactability, NP-hard problems and so on and so forth. So lots of mathematics is also there in the foundations of AI. If we talk about the another dimension, which is economics, definitely yes. So we have kind of operation research which is being involved in artificial intelligence, because ultimately we want to maximize the performance of the agent while minimizing the resources which it is going to consume. So it is kind of satisfying versus optimization. So that dilemma, economics is definitely involved. Then in the first lecture we looked into that it is one dimension, it could be how this your human brain is working. So in order to study how human brain is working, we need to delve into neurosciences definitely, because we need to look into how do brains process the information. This involves study of neurons and various comparisons between the biological human brains and the digital computers definitely. So kind of neurosciences involved. When we talk about concept of brain as an information processing device, that means we are talking about psychology, somewhere between cognitive psychology versus behaviorism. That approach or dimension is also involved. Next foundation is computer engineering and control theory. So definitely it is there, because we need hardwares to run all those AI programs. So definitely computer engineering is required, and it is working on homeostatic systems and some feedback loop, which we are going to talk definitely in our upcoming lecture. So control theory is also involved. So if we look into foundations of AI, we have, and obviously when we want to build a complete humanoid robot, that means we are talking about some mechanical engineering also. So whether it is computer engineering, control theory, mechanical engineering, psychology, neuroscience, economics, maths and philosophy, so all these subjects, all these faculties defines the foundation of artificial intelligence. So moving forward, artificial intelligence is actually something which we have started hearing some 10-15 years before, 10-15 years ago. So is it actually kind of is it that recent field? But if you look into the history of AI, the birth of AI or the artificial intelligence as the official name or as the coined name comes from 1956, but before before even this, when we look into the history of AI, we call this period of 1943 to 55 as the kind of gestation period. Gestation period in the sense, kind of preparation, foundation has been started. Although there was no formal term as artificial intelligence as we have it today. But in this period, which is 1943 to 55, McCulloch and Pitts have given their kind of initial neural network model, and first neural network computer, which is named as SNARK, was built by Edmonds and Minsky. So from there we kind of we call it as a gestation period, because this AI has started kind of reaping in, the foundation has been started. Now, if we look into the formal naming of artificial intelligence as the official one, this credit goes to the Dartmouth workshop, and within that workshop, this McCarthy, Minsky, Shannon, and Roster, they have given the name, which is artificial intelligence, and it has becomes one of the official terms which we also use nowadays. So if we say okay, we have started using it, or we have started hearing this artificial intelligence maybe a couple of decades ago, but the actual term was coined way before. This is nothing but 1956. Then from 56 to 69, I can say there was a kind of early enthusiasm in the industry towards this artificial intelligence. Then they kind of coined a GPS, which was not the global positioning system as we hear nowadays, but a general problem solver. And there was a prediction by Herbert Simmons that machines will do what men can do, and then from that particular point onward, it was believed that okay, artificial intelligence or an intelligence can be built into the machines, although it is artificial, or it is being built in an artificial manner, but that can be kind of done. But after this whole enthusiasm towards the early 70s, if we talk about 1973 onwards, we talk about the term as the AI winter. So when we are talking about AI winter, that means not much of the work is actually being kind of done in this AI winter term, and some machine translations actually failed, and people have stopped talking about much of the AI, and that's why that period is known as AI winter. But moving forward, if we look into that, in 1952 to 70, there was a GPS, general problem solver, and the predictions that machines will be able to do what man can do, followed by some AI winters. In the period of 1969 to 1979, there were some knowledge based system, although they were kind of we can say rule based system, but yes, some kind of artificial intelligence. So for example, two names are very prominent here. One is Mycin, which is in the field, which is a knowledge based system in the field of medicine. Then another one is Dendral, which is the knowledge based system in the field of chemistry. And now from this GPS, which is general problem solver, your focus is shifting from general search to domain specific knowledge. Moving forward, when we kind of entered into 1980s, this AI has become an industry, and so many expert systems and projects are being kind of worked upon. There was an expert system which was kind of like the R1 system at DEC, and the Japanese 5th generation project. All those projects are getting prominence in the industry, and hence your AI has also started become industry, because at that time 1986 onwards also there was a return of neural networks, because that neural networks was way before coined, but then maybe lack of enthusiasm, AI winters for some particular of point of time, neural networks were not much talked about. Then these neural networks, your back propagation algorithm, all these actually kind of bounced back or returned starting 1986. And our course, which is about the study of intelligent agents, so emergence of these intelligent agents actually happened 1995 and onwards, in which your or the focus of the computer scientist or was on a whole agent in an environment. And from there, so 1995, the 5 years ago, 1995, which is 1990, was another remarkable event, which was invention of or starting of World Wide Web. So this 1995 was actually a time when internet was kind of, we can say, growing, and lot many bots, which are actually one kind of agent, were kind of getting prominence or getting so much of made. So emergence of intelligent agents, which is starting from 1995 to present also, it is happening, and now we are talking about generative AI, agentic AI, and so on and so forth. So now if we look into looking into the brief history, we have seen looking into the state of art, what actually AI can do nowadays, what is being kind of given as the inputs. So nowadays or we can say 1 decade ago, there was a big data revolution. That means there is an availability of large data sets. So this requires, or this has triggered the transition from algorithmic centric to data centric AI. And now we have deep learning or modern AI, which I was talking about, which is agentic AI or generative AI. And we have built so many success theories in terms of speech recognition, computer vision, and other LLMs, which are large language models. So AI has traveled so very fastly, I can say, but with this growth there is other kind of, or that is the another, we have another side of the coin also, which involves some risks and some ethics with this AI. So for example, if we talk about AI ethics, so we have some systems which are biased, we have some systems which are triggering the issues of safety, and there are some systems which are triggering job displacement. So job displacement is we can say one of the major concern which is related to AI. I would rather name it as a paradigm shift, because when we when the men started from doing manual work to the computer, that time also this was a thought that this is going to kind of snatch so many jobs and so on and so forth, but jobs were there, or that was a paradigm shift. Similar kind of paradigm shift is kind of here in my personal opinion. If I look into bias, so yes, there are systems who are actually biased, and you must have heard of I would not name the company, that HR system which was actually kind of sorting out the resumes for candidature for a particular post, and that particular system was actually biased towards the towards a specific gender, and for women it was kind of taking them out, just looking at the gender because of the previous feed in data that was in that shape. So it has learned that okay, if this is the parameter, I need to need not to consider this particular resume. So that was kind of a bias which was unintentionally, definitely unintentionally is built into the system. So yes, AI systems can be biased. So we human being as the controllers need to look into all these things. And also there are safety issues. Definitely safety is actually a critical point which is related to AI. We are definitely going to talk about these safety issues of AI. Just one example, that there was a news some weeks before that one child has asked this one of the chatbots, not the chatbot but one of the AI tools, that what is the which is the way to do the suicide, which is the way to perform the suicide. So that kind of that very tool has given so many ideas about the suicide, and even how to tie the knot for hanging themselves on was taught by the AI tool. So definitely safety issues are there, we need to look into that. Apart from that we have what we call it as the alignment problem. So alignment problem is actually the challenge which is obviously an urgently need to be addressed, and it's a complex challenge of ensuring that the AI system not only perform competently but also align with the human values and ethics. So human values and ethics alignment along with the efficiency is also kind of one area of the concern when we talk about AI system. So it is not just the speed, it is not just the efficiency, it is not just the work. We also we also need to look into the another side of the coin. And if we talk about the question that what an AI can do today, so the most kind of sophisticated if examples I'm going to talk about, medical diagnosis is kind of so much automated with the help of AI. Then robotic surgeries, we are hearing nowadays success stories of so many robotic surgeries. Also we have those autonomous driving cars, and definitely other areas which are being flourished with the help of AI. So all these kind of systems are in place today. So we can say AI can do or at least AI can help in every domain, in every sector nowadays. So when we say that how this AI is going to work, so the heart and soul, or as I've told you in the previous lectures also, that what we are going to study in this course is intelligent agents. So from this general talks about AI, I am going into the specific specifics of the course which are tied up with the definition of agent or intelligent agent. So first of all, let us try to understand what is agent. So agent is something that perceives its environment using sensors, and it is also something that acts using actuators. So for example, let us take the example of a human being. So a human being kind of the sensors through which it perceives its environments are actually eyes and ears, we can say, and nose, and the actuators through which a human is going to act is the kind of hands and mouth, we can say, and obviously legs are there. Similarly, if we talk about robot, robot is also having these kinds of sensors through which it perceives its environment, and the actuators through which it is acting upon the environment. Not only the human and the robot, but we can also compare, or we can also understand software as an agent or software agent if we talk about. So it is going to take some input which is kind of an sensor, and it is going to give some output which is nothing but an actuator. So this agent actually operates in an environment. So for example, if I am talking about a human agent as an agent, the whole aura around the human being is the environment. If I am talking about a vacuum cleaning machine as an agent, so the environment or the area, or specifically we can say the room in which it is operating, in which it is being kept on, that is the environment of that vacuum cleaning machine. So now environment, if we want to kind of understand, we say everything which is external to that agent, in which that agent is operating upon, is the environment. Now this environment can be physical or it can be virtual, as in case of software agents we have looked into. Now this environment definitely is going to influence the decision of agent. So for example, an automated taxi. So automated taxi definitely around will sense the external environment and will apply the brake or the accelerator depending upon what is going on in the environment. So if it is a red light, then it has to apply a brake. So definitely your environment is going to influence the decision of the agents, and also it is not only going to influence the agent decision, but it is also going to determine the complexity of the problem. So more complex the environment is, we can say complex is going to be the problem, or complex is going to be the functionality of the agent. So basically your agent is going agent acts with the with the environment in an actually we can say loop kind of thing. It actually does something with it senses, takes some inputs, perceives the environment with the help of sensor, and then it does something, act upon, which is taken as its output. So agent and environment, as you can see in the figure, are going to work with each other in as hand in hand, and they agent operates within the environment. Yes, we can say that agent operates within the environment with the help of sensors and actuators, which are nothing but we can say these are the input devices, or input and output mechanism. We can say devices may not be a perfect term here, mechanism. So sensor is an input mechanism and actuator is an output mechanism, in which your agent is going to deal with the environment, in which your agent is going to work with the environment. Now when we talk about the agents, what kind of agents we kind of want to build? We actually want to build rational agents. Rational agent means rational agent is something which is going to choose the action that maximizes the success, and it depends upon whatever it has observed, and it also depends on the available knowledge. So rational agent means the agents which are going to choose the actions that maximizes the chances of success. Now how this success is being evaluated, that's also I can say is a $1,000,000 question. Now how this success is going to be measured, how this success is going to be evaluated, is actually kind of depending on the task. So for example, so that is task specific. So if we talk about a vacuum cleaning agent, so the success is the clean environment. It should be kind of the environment should be clean, there should be no dust, and that should be done with the minimum we can say power consumption. So that is what the performance measure is. But on the contrary, if we talk about the agent which is automated taxi, then safety, speed, legal driving is all are the performance measure through which we are going to evaluate the success of that particular agent which is automated taxi. How safely it is driving, what is the speed, this should be kind of within the limits, allowed limits. Then apart from that, this kind of this should also give a good fuel average, and so on and so forth. So these could be performance measures. Performance measure always is going to be task specific, through which we will be able to evaluate the success of an agent. So, for example, now let us look into in order to understand the concept of environment and the task, we look into a vacuum cleaner agent as an example. So, for example, we have two areas A and B, and there is a vacuum cleaning agent, and the circles which you can see on the screen are actually the dust being shown. So, what it is going to observe, it is going to observe dust in one or the another area. And now if I am going to say, or if I am going to give an input, if I am going to give a percept which says A comma dirty. So, A comma dirty means the location is A and the contents are that the A is dirty and it is containing some dust. What kind of action should this vacuum cleaner agent should take? It should suck the dust. So, the possible actions could be move to left. If it is in the B, it will move to left onto the A if it is required. Then if it is in A, it will move to B, that is move to right. If there is dust, it is going to suck the dust, and if there is no dust, it will do no operations. So, the possible actions could be left, right, suck and no operations. Then percepts, if we talk about, percept is going to what we give into in terms of locations and contents in this particular example, that means what it is observing. So, a vacuum cleaner agent within this particular example can observe in which area, in which location it is in, and what are the contents of that particular area, whether it is clean or dirty. So, A dirty is one of the percept and A clean is another percept, B dirty and B clean. So, now how this simple agent, this kind of vacuum cleaner agent will function. So, a simple agent function will be if current square is dirty, then suck, otherwise it needs to move to the other square. And if we talk about the performance measure, so what kind of performance measure we are going to expect here in this case of vacuum cleaner agent. So, that is nothing but actually the cleanliness, that means absence of dust should be the performance for a good, or we can say a rational agent here. Now, the question comes up, who decides this? So, who decides this in the sense that who is going to decide the whether this agent is performing or doing best or not. So, that depends on the environment that has been actually decided by the controllers. So, in this lecture we looked into the agents, and before going into the agents, we look into the foundations of AI, which involves or which contains so many interdisciplinary dimensions, be it philosophy, control theory, computer science, mechanicals and so on and so forth. After that, we looked into what is an agent, what kind of environment it is kind of we can say operating upon, what actually rational agent is, and what is performance measure. We we have seen, we understood all this with the help of an example. Here is a list of reference which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next. Till then, take care. Goodbye.